Good evening, Mayor and City Council. Thanks for inviting us to share the latest on the traffic signal system in Fredericksburg. As y'all know, over the course of the past year, we've been working to improve the communications of the signals. We've contracted on Iteris, a consultant firm, to help us with that process. Mr. Nader Ayub in Fredericksburg. As y'all know, over the course of the past year, we've been working to improve the communications of the signals. We've contracted on Iteris, a consultant firm, to help us with that process. Mr. Nader Ayub will be with Iteris, will be providing this update. Mr. Ayubi has over 34 years of traffic operations, including 3 years at TTI. He has 11 years at had 11 years at TxDOT prior to that, and 9 years with Iteris. He's a signal operations specialist, and his experience is concentrated on the areas of vehicle detection and control systems design, ITS communications design, ITS signal system implementation, and ITS project background in signals and ITS and how they all communicate together. So with that, I'm going to turn it over to Mr. Ayubi to give y'all an update.
Thank you, Mayor and Council, for the opportunity to present before you. Most recently, TxDOT has been under a very aggressive plan to upgrade the traffic signal system, not just in Fredericksburg, but district-wide. And so I'm here to give you an update on the status of their plan and the progress of that plan. So when we start talking about traffic signal systems, we're really talking, the current terminology for it, because it changes a lot, is advanced traffic management systems. So it's not just traffic, it's actually managing traffic. It's not just traffic signals, but it's all the components to the operation of a roadway, the electronics part of it. And it's really dealing with the technology. So that's what we'll be concentrating on, the advances in technologies that TxDOT has implemented here in Fredericksburg, as well as district-wide. It's a total solution for traffic management and congestion management. So it's not just about the equipment, but it's also about the operations. And finally, it's a mechanism that uses technology to make us more efficient, to make the operation of traffic signals more efficient, make the man use, the labor of TxDOT and the use of the resources more efficient as well. And data collection mechanism also so that we can make better decisions. The better information we have coming from the field, the better decisions we have for making adjustments to traffic signal timing. So what does it do? It really has a series of hardware in the field that collects data, feeds it back into a control center, and lets us make decisions remotely and help a lot with the time constraints of, instead of managing a signal system by having to enter it remotely, make decisions remotely, and implement things very quickly. Response times can be greatly reduced, and the efficiency of the system can be greatly improved. It involves multiple devices, not just traffic signals. It involves signal timing, changeable message signs, as well as lane use signs. The common thread in all these things is a common communication platform. And that's the big advancement that TxDOT has just achieved here in Fredericksburg. So when we look at an overall traffic management system, there are many components to it. The traditional things you think about, the traffic signals, the signal timing, are some of them. But there are many, many other aspects of it, and so I'm going to show you kind of the building blocks that are being implemented right now to help achieve the final goal of an efficient system. So the real goals from all this is highlighted there in the red. We want to be able to monitor traffic signal operations, measure the traffic, and not just monitor but control traffic signal operations. And that's the key to the system that's being implemented now. And as a final result of this, hopefully we'll be able to manage the manpower and make things more efficient, again, time-wise as well. The major components of the ATMS system are right at the top, probably the critical components: control software, central software, and also the remote communications to the system, so that you don't even have to be in your office to respond to a call late at night. You can do that remotely from home as well. So when we start talking about the field equipment, the first components of it are the controllers. That's the brains of the operation. On every traffic signal intersection you have here in the city, there's a big aluminum box. In that, that is a power, so we protect our electronics, but that's where all the decisions are made. All the detection from the field comes into that one spot, decisions are made, and then the timing adjustments are made automatically by that central computer. The system also monitors as well as provides information back to the control center back in Austin. Remote diagnostics is a huge aspect of the system. Not only getting back how well the signal operations are running as far as the traffic is flowing, but we also monitor that the things are running as efficiently as possible. And through this mechanism, we have the ability to have a quick response. One of the most frustrating things that the public experiences is if they feel like they're not being responded to. If something happens in the field and it takes a long time to recognize it, and then do a long time to recognize it, and then do something about it. This process helps this equipment helps in that process. Remotely monitoring and then remote control from from Austin or some other remote location. The communications. This is the big improvement that has happened just recently. District-wide, the TxDOT Austin District has invested a lot of money in increasing the communications. Without the communications, it's necessary to drive to every location whenever there's any complaint. To verify the complaint, then you hope you have the right equipment when you go out there to fix the problem. And if you don't, you have to go back to Austin. This system, through the communication network, gives us not only the eyes and intelligence to make the decisions to improve the efficiency of the operation. The system that's deployed here in Fredericksburg is a wireless network. It is a broadband communication network which is capable of communicating to multiple devices. So very similar to your computers at home, where you can network many computers and printers and other devices together. The same thing happens here. That one communication path has the ability to control traffic, get the data from the detectors, get error logs, so for troubleshooting, and communicating all through these other devices through the one, and that is what hasn't existed here before. The central control system, the software that resides back in Austin. It is a package called Centrax. Centrax has the ability to communicate to every traffic signal in the district, as well as monitor the health of the detection, control changeable message signs, and it is really the brains of the operation. It not only gathers the information, but also helps make some of the decisions. Through this system, you actually get to monitor how well the signal timing is, for example. If you're monitoring the roadway and a signal needs more time on one approach, this system indicates that, so that you can actually start making timing adjustments before people start complaining about it. It communicates to all the intersections in the field. One of the requirements of it is it does need to have the same brand of equipment. TxDOT has upgraded all their equipment to the same brand, so they can take the greatest advantage of the software that they've deployed back in Austin. This software also monitors the traffic flow. When anomalies occur and something is taking longer, that vehicles are having to wait longer than they should, more than one cycle, we actually get indicators so that we can be proactive in making timing adjustments instead of reactive to complaints from the field. and that is a huge advantage. So we can monitor from the control center how well the signals are working together. So not only do we watch one traffic signal operate, we also watch the entire system and see how well it's working together. An interactive map makes this very intuitive and simple. This map has an indication of, this map has an indication of the state of the signal of every one of the traffic signals in the city. So here's a snapshot of the city of Fredericksburg signal system. And again, allows us to monitor for any kind of malfunctions in the field. If a traffic signal goes to flash, this system will know it before anybody calls in. And one of the things that is very difficult to do from a signal operations perspective is to get all the information you need from phone calls from the general public. The public always calls when something happens. There's no doubt they are aware of it, and the problem is they don't necessarily know how to translate what they're seeing in the street to useful information for the traffic signal technicians. You know, the signal's on flash. They have no reason to know why, and so traditionally what we would do is drive out, evaluate the system, figure out what was wrong. If a piece of hardware was, drive all the way back. The system, when a signal is in flash, we actually can interrogate other devices in the cabinet that are, their sole source or purpose is to tell us what's going on in the cabinet. And we can make good decisions on what equipment to take, what resources to bring. Do you need a bucket truck because a signal is down? That type of thing. Or can you just get away with having a pickup truck with the electronic components for the controller? Those decisions make the response time much, much faster and our time much more efficient. When you start at that big map, if you click on any one of the intersections, you get all the information at the local intersection that you would if you were standing at the intersection. Everything that the controller is doing, you get to monitor, and you get to see the health of the equipment, and you get all the diagnostic logs of problems. Again, reducing the response time, and many times problems can be taken care of from back in Austin or anywhere you have access to the internet. It also allows you to have hyperlinks. So on this map, on that diagram, you could have hyperlinks to your cameras. So the capabilities, and so you know where the district is going and where they are now are two different things. But the capability is here through this communication system and this software to not only monitor but also observe traffic. So the mechanism is there to bring video back to the area office, back to Austin, so that really intelligent decisions can be made. That part of it isn't there yet, but they're very close. The building blocks to get them there are in place now. So the next step, I think you'll see, and there's some issues, internal TxDOT information back to Austin right now, is first of all, we have these radios that get everything back to the area office just next door. And then it's on the business network for TxDOT, which is limited bandwidth, that gets it back to Austin. It's limited and can't handle video at this point. But TxDOT is looking statewide on how to increase bandwidth for their business network to be able to use it for traffic. So hopefully that decision is going to be made quickly, and that capability will be in place very soon. Then the other thing, so is the data that's available. We get to monitor how well every phase is running. If a green arrow for a left turn is using all of its time every cycle and needs more time, the system will let us know. So again, before people start complaining, we'll get feedback. We'll get feedback from the system so we can be proactive and make those changes. That information can be used to do many things. It can be used to populate changeable message signs. Again, I live in South Austin. I grew when the Christmas parade is on. You have to have some diversionary paths. Some of the visitors don't necessarily know. This system can actually support changeable message signs that would help guide visitors in a scenario like that. So a very powerful system. Currently, the TMC, the Traffic Management Center, resides in Austin. There are different forms of TMCs. Austin has the extremes and everything in between. Their control center at the old Mueller Airport, it looks like a mini NASA. Well, not mini, it's probably bigger than NASA, if you want to know the truth. It houses many agencies, TxDOT, City of Austin, PD, Fire, for emergency management. That is manned 24 hours a day. And then all the way down to the local office, the signal shop, that has PCs that reside there on all the time. It's important to have a central point for data integrity. If multiple technicians go out in the field and make changes, everyone's database would be different if they had unique databases. Everything is always managed from the control center, so you have one unique database. So any change that's made now is going to be maintained for the future. And everybody's going to be aware of it. So monitoring communications is all the central point from the TMC. Because they're on the business network, anybody who has remote access for their business network has remote access to monitor this system from home or from wherever they have. So that's kind of the architecture. So one of the things that I want to kind of go through is kind of typical applications. You know, what do people really see in the field? What kind of calls does TxDOT have? And how can this system help alleviate those problems faster than what we've been doing in the past? A very common problem. This happens a lot of times with traffic signal accidents. Everybody had a green. You'd be amazed at how many times even report, the eyewitnesses say everybody had a green. This system actually has the ability to log every 1/10 of a second everything coming in and out of the controller, the status of the greens, the detection, everything. So technically, we'll be able to tell you, if you can identify the time, because the biggest problem at this point is people don't really know what time they were waiting at a traffic signal. But if somebody says, an accident happened, all these things, say the controller at that second, these signals were green and these other signals were red. Those capabilities are there with the system you have here in Fredericksburg. I've been waiting too long. This system, again, has the ability to monitor if we get that call, and we can watch the traffic signal operate. We can see exactly how long they're green. We can see if the cars are still on the approaches and if they had enough green time. So this system monitors and controls. So remotely, when we see this happening, we can make signal timing adjustments. That left turn needed 20 seconds instead of 15. We can remotely change that instantly. I got skipped. Very common problem or complaint that we get. Again, you can monitor it. You can monitor from that system map. You can see the signals changing colors. If it's not because of a detector failure or something like that, remotely we can put in a call right now so it starts cycling, instead of having to drive somebody out for an hour and a half and having a signal in a malfunction state for an hour and a half. I had to stop at every traffic signal. Again, we have the ability to monitor and make reports on the quality of the progression. Using that system map, we actually know and we can watch a series of signals turn green to make sure that the cars are flowing through the city properly. There are engineering reports for every one of the traffic signal systems in the district that show the offsets, the time offsets, the time from one going green to the next going green, and that can be verified by observing this map. So again, something that would have had had an engineer have to drive out here and observe it and make adjustments can be done remotely, reducing time and making the most use of the TxDOT resources. So what are the real benefits of a system like this? Well, efficiency on two levels. First of all, on traffic. The signal system will be coordinated better. The time clocks will be synchronized at the top of the traffic signals is better. And as well as the efficiency of our human resources. TxDOT, you guys experience this. Little traffic trivia. For every 1,000 people in your city, you have a traffic signal. So as you see your communities grow, the traffic signals are growing. TxDOT hasn't been able to hire and expand staff in many years. So the reality is growing infrastructure to maintain, and we have to do it with fewer people. Systems like this help us do that. And that's really the benefit of this, is we can better service Fredericksburg from Austin to past. And that's the true benefit of this system. Safety. Roadway safety, because signals, if they are malfunctioning, won't be malfunctioning as long. We're going to respond faster and get them up sooner, and that's going to improve safety and the safety of the personnel. There's nothing more dangerous for any kind of personnel. There's nothing more dangerous for any kind of personnel that works in the safety industry than to be outside their vehicle on the street corner. So this allows us to do a lot of the troubleshooting and adjustments remotely in a safe environment instead of having to be on the street. Another huge benefit. And quick response time. And I think that is one of the things that benefits the public the most, is that quick response time. With that, I'd like to, obviously thank TxDOT and the suppliers of the equipment, the folks from Paradigm, the area office personnel. We have representatives